are don't forget the fun functions. I think that's so funny. You guys are looking at me like this dude's freaking crazy.
Yeah, but I've been looking the past 3 years, so I know you
on my
are.
paper, and my mom was just like, "Do you know how to write in English?" And I'm just like, "What's wrong, Mom?" She's like, "Capitalize."
Okay, so you have a parent function. Remember, we're basing it, just about everything we do off of parent functions this unit. It helps you a ton if you have these just stuck in your mind, memorized. Like you have a blue sheet for your test, which is great. But if you have these memorized, it makes things a ton easier, especially for next year when you have to have it memorized for calc or stats. Okay. So, does anybody remember what that looks like?
A lot.
Isn't that the one I played in?
No. Yeah, it is exactly like this.
You got it right.
Again, we're just sketching. Parent function right there. Okay. Do you remember what asymptotes are from yesterday?
Yeah.
Okay, so what are the asymptotes here?
Y.
0. Okay, and they have to be an equation of a line. So vertical and horizontal lines are either x equals or y equals, right? So 0 is not an equation of a line.
Y equals 0,
okay?
X equals 0.
And x equals 0. Thank you very much. Now, how do I know that the x equals 0 occurs? It's determined by the denominator. Right? The y's I'm going to get into a little bit deeper. It's line that the graph, the equation approaches, but never crosses. Or as, let's say, as x approaches infinity, y approaches 0. And that's how we would describe this one. You can cross it, but as long as it comes back to it, it's okay. I'm not going to throw that at you, so for your purposes, this is
So
fine.
the asymptote is like what the function is working towards as the end result, right?
Yes, the end behavior. You're looking at end behavior here. So, x equals 0 is that one. So as x. So we're looking at end behavior basically. Does y equals x squared have any asymptotes? No, because this approaches infinity, correct? So if this approaches infinity on both spots, we have no asymptotes. Right. Again, that's the main point of today. So what about this one? I heard it. I'm thinking of a response. Your answer, mathematically perfect, is yes. Am I going to ask you to worry about it? No. Sweet. Okay. Okay, the graph, what about the graph of this? What happens?
It shifted to the left.
Right.
Or right.
Shift to the right too.
Right 2 units, correct. Okay, so our horizontal asymptote
So
and
it'll
our
be
vertical.
1, wouldn't it?
So That's right. So what is our horizontal? Asymptote. 0. Y equals 0. And our vertical because the denominator 2 minus 2 is 0, right? So vertical asymptotes are much more straightforward than horizontals. So
Does the negative 2 under the fraction?
what?
The negative 2 is with the x, right? Under the
Correct,
fraction?
yeah, it's paired with the x, so that's enough to write with it. What about, you probably guess when we're right here. Yeah, down 3 units, right. So we can do all the parent function stuff to rationals that we studied. This should all be review except the asymptotes. Minus 3. It's getting kind of messy. Okay. What's the horizontal asymptote here? Negative y equals -3. I tried. Vertical is 0 because that makes the denominator 0. Right? So the vertical asymptotes are pretty straightforward there. One last one, and then we'll be done making a mess. Remember what the negative in front does? X-axis, math word, what's the math word for flip? Reflection, thank you. An inverse flip, an inverse is a reflection over y equals x. So that, so you take the black one and you reflect it. Okay, are we good?
Yes.
So the graphs, this is the main point of this slide, the graphs, and give you an introduction to what an asymptote is. Okay. How do you determine, so, vertical asymptote.
So, is the absolute value in the brackets or out of the brackets?
Out of.
Out of the brackets, goes up, down, in the brackets, goes left or right?
So we have vertical asymptote is 0 here, right? Just like the graph we had, because the denominator is 0. Right? There's a situation where this doesn't apply. I'll show that to you. This is what we call an infinite discontinuity, right? If you look at the graph, it goes to infinity, right? As opposed to a hole or a small jump, right? Yes. So there's a point where that doesn't apply. It would be something like this. Okay, where is the denominator 0? At 2, correct? But what does it also do to the top? It also makes the top 0. Okay. So if you get a number, if an x value makes the bottom and the top 0, this is a point discontinuity. Okay. So this is what we call a point discontinuity. Okay. That's because x equals 2 makes the numerator and the denominator 0. So we can't assume this always works. You have to plug in to the top. So if I put 0 in here, I get 0 at the bottom, correct? Does it give me 0 at the top? No. I'm okay to say that this is a vertical asymptote.
When the point is going up and down, it's right street, go down to your right, that's where it's opposite of left, right, it's going to be that way up down.
Keep that in mind.
Is that x equals
2. 2.
That's why I asked.
Doesn't matter. If you're looking for vertical asymptotes, you're just looking at what makes the denominator 0, doesn't make the numerator 0. If the answer is no, you have the first case. If the answer is yes, you have a point discontinuity. This will matter a lot more for calculus. Right now, not a big deal, but I want to introduce you to it. Okay? So that's vertical asymptotes. Okay? I'm going to hold you to this. Will not present this like that. Very good. Okay. All right. Horizontal asymptotes.
Is that more like, is that what degree?
Minus. I haven't had this word for a year and a half, and I've never gotten used to writing on it. My handwriting completely changes on that whiteboard. Okay, next slide. Horizontal asymptotes. There are a few ways you can get me distracted. That's not one of them.
I think that's why I didn't hear anything on the walker ever wanted to talk about was science. So we spent like an hour and a half of our class for science and figure out how to.
The best way that I can explain horizontal asymptotes is not in your book. Okay? So we gotta pay attention this time. It's very similar to what's in the book. I just make it easier on you. Right? So if I have an equation like this. Okay, I've added something in the top. 3x minus 2. To determine horizontal asymptotes, you got to consider the coefficients of highest exponent of x. Now it's very mathy, right? What are the highest exponent? What's the highest exponents of x, top and bottom? 1, right? So x to the first and x to the first. Right? What are the coefficients? 3, 4. There's your horizontal asymptote.
What?
The Okay, yeah, I know,
So
you're
you
like,
do
wait, that was
highest,
too easy.
so you do,
Highest exponents, right?
yeah,
3x and 1x, right?
so you just say.
The x's will cancel. Okay, this is not formal math. This is the easy way to determine orbital asymptotes. Okay, so y equals 3 is the horizontal asymptote.
So is
It's
it?
not witchcraft. I don't engage in that crap.
Does it work every time?
So,
Wait,
Well,
just tell me like what, okay, it's what over what? It's the exponent.
Okay, grab the highest exponent, top and bottom, which is 3x and 1x, right?
So,
And then the x's cancel. You have 3 over 1.
no, like I made the math part, I just simply need to highest exponent, like so it'd be
Yeah.
that and then over what?
The highest exponent in the denominator,
What's the three, what's the
coefficient.
So it's the coefficient over the exponent.
Coefficient, it's this term
Yes, and then over the.
over the highest exponent
Is it always like
term.
that?
Yes, this works every time.
Works with them. And, so what if it was x squared? Because you said consecutive coefficient, so if it was x squared.
On the top,
Yeah.
okay. I'm not gonna, there's a problem in the book that I actually skipped purposely because of that.
Okay.
Okay, I'm not gonna hold you to that knowledge. It's number 6. There are actually no horizontal asymptotes.
So if it's x squared.
Or it's a slant asymptote.
Double check.
Okay, we're not worried about slant asymptotes, but if you run into something like this, you're looking at slant asymptotes.
So the highest exponent value has to match?
Yeah, if they do match in this case, right, that's your horizontal asymptote. But again, I'm not gonna throw that at you. Just this, that is. So you either have this case, right, or that case.
That's bad.
These are easy because they're y equals 0, right? There's no exponent. So let me write that up. So here's an example. What's the highest exponent here? X to the 0 power. There's no x, right? So the horizontal asymptote, there are 0 x's over 1x, which is 0, correct? So the same method applies, or you can just remember, there's 0 x's. So you have an x here, one of them. So 0 x's up here. So your horizontal asymptote is y equals 0. Same method, you just have to extrapolate that 0 x's happen. So same thing. Good? So it's either y equals 0, this case, number on top, or you have this case, which you do a little math back.
so.
Witchcraft.
This guy's ridiculous. He just keeps doing it.
So,
No, we take the coefficients of the highest exponent of x. So here's the highest exponent of x, here's the coefficients. Highest exponent, coefficients, 1. Okay, we don't have x here, right? There are 0 x's, or it's x to the 0, which is non-existent. There's one of them here. Just take those terms, that's it. You can, like, cover that. Done. All right, Leah.
So let's say that on the bottom, like in the first one, is another derivation. Yeah, so let's say that it was x squared. You'd use that, it'd be 1 over x, correct?
At the bottom, it would be the same situation with this. So if I had, if exponent, highest exponent term, eliminate the x's if you can.
So it's the leading coefficient. So it's still in there.
This here. I'm not gonna throw one of these at you, but it's the same method as these.
Okay. So, just a quick question, you can have an asymptote that's a fraction, right? So
Yeah.
it could be 3x over 2x?
It could be 3 over 2x, 3 over 2 could be your horizontal.
Okay.
Yeah, fair game, for sure. Okay. Maybe we can go back to that. You're asking some great questions, and I like it. As a math teacher, I love it. I would say those deeper questions, I can answer them now, but just think about it as in, I will need to use it next year. Okay. So, let me make sure I cover it. Okay, I think we're good. Yep. So that's it. Your graphing rationals, which we've been doing, parent functions, and you're determining asymptotes. Denominator 0 for vertical, horizontals, here's your method. Okay. There's something on top here. So there's 0 x's and the x is 0 divided by 8. Or here's how we think about this in more calculus terms. What happens if I put a really large number in here? This whole thing gets really small, and if I put a bigger number in, it gets closer to 0, right? Closer to 0, closer to 0. So we're going towards 0. There's your asymptote. So if you're thinking in terms of motion and movement, as this goes to infinity, the whole number goes to 0. Another way to think about it.
Wouldn't that be true for all graphs?
So these, what about this one? If I put really big numbers in, a million and a million, it still goes to 3, right? It's 3 million over 1 million. So, don't make it too complicated on yourselves. Try to keep it simple. Half the battle in math is trying to keep it simple. Yep, that's it.
Have you seen the stuff you give us? It's not simple.
I said try to keep it simple. For you, it's not. I know. Don't overcomplicate this one. Okay. Okay, but you have, I don't know, what's today, Wednesday?
Yeah.
Till 30, you got 10, 12 minutes, so get some of these things looked at. Ask questions if you have them. Okay. Score it tomorrow. History, I'm gonna go.
You look like you're like meditating or something.
You want to look at it right now, and then you can start it over again. You turn the video off, so that's let's get to work, guys.
I honestly can't blame you.